Here we have a sick child that is given a fever-reducing medicine. The child's temperature, capital T, is in degrees Fahrenheit, and lowercase t is hours. So you give a fever reducer and this T of T models it. So tell me how many hours later and we'll tell you what their temperature is. So we want to go off to the side. I'm going to set up our units. So T of T is the original, and that looks like you plug in hours and you get out the temp in degrees Fahrenheit. But then we're going to take T prime of T. Remember, a derivative is going to have 2 units, so it's going to be in degrees Fahrenheit per hour. That's going to tell us the rate of change is if we're going up in degrees Fahrenheit per hour, or hopefully it's going down, so that their fever is reducing. And then if we have to take the second derivative, which it looks like we do in part C, it's going to be in degrees Fahrenheit per hour squared, which for this one I would probably just describe this as degrees Fahrenheit per hour each hour, how that rate of change is changing. This one's going to be a little bit trickier because we're going to have to interpret a second derivative, which we'll talk about when we get there. So the first part says find T of 0 and T of 4. So we're just plugging into the original. What was the original temperature? And what was the temperature after 4 hours after taking medicine? So normally that's kind of about how long these medicines work. They say like sometimes 4 to 6 hours or something like that. If you took Tylenol yesterday, it doesn't affect you now. Just like drinking alcohol, like it might affect you for a few hours, but probably 5 days later, you're not still feeling drunk. So any medicine or anything going through your bloodstream is going to eventually kind of just not be there. So we want to see what's happening after 4 hours, which is it's a reasonable time to put in there. If we put in 24 hours, it's probably has nothing to do with the fever reducer that we took. So T of 0, I'm plugging into the original. I have 103 minus 0.9 times the square root of 0, which is just going to give us 103 minus 0, which is 103. So a temp of 103, but this says it's a child. So kids run high temperatures in general. So if an adult had a fever of 103, we'd feel like we were dying, but kids just run higher. So this might not be the worst fever that you could think of. But let's see what happens 4 hours after taking the fever reducer. Hopefully it's gone down at least a little bit. I mean, if they're still sick, it might not be back to normal, but let's see what it is. So I'm plugging into the same function, and in my calculator, I'm getting 101.2 degrees Fahrenheit. So it's gone down a little bit, so they're probably feeling a bit better, but not back to normal. The next part, we have to interpret our answers. Yep, that's our next part. So for this, I would say initially the child had a 103 degree fever. That's what I would get from the first part. And then T of 4 tells me the temp of the child and we're doing 4 hours after taking the medicine is 101.2 degrees Fahrenheit. So initially the child had a fever of 103 degrees, and then the temp of the child 4 hours after taking the medicine was down a little bit to 101.2 degrees Fahrenheit. Just interpreting, plugging into the original function. The next part says find T prime of 4. This is another one that looks like it's one problem, but you have to do 2 different things. First thing we have to do is just find T prime of T, and then we'll plug in 4 to it. So first thing I would actually want to do is rewrite T of T, because I have a square root in the original problem. So I'm going to rewrite that before I bring down the power. So I really have 103 minus 0.9, and the square root is t to the 1/2. There's my original function. So the derivative is going to be the derivative of 103, which is 0. And then I have to bring down my power. I would have negative 0.9 times 1/2. And then I have t to the 1/2 minus 1. 1/2 minus 2/2 is going to give me a negative 1/2. So we could leave it just like that. We could also grab our calculators and just combine those constants. So negative 0.9 times a 1/2 or 0.5 is really a negative 0.45 t to the negative 1/2. But it doesn't just ask for the derivative, it asks to plug into the derivative. So we're going to do t prime of 4. So negative 0.45 times 4 to the negative 1/2. And we want to see what we get for that. How is the temp changing? Now the temp went from 103 degrees to 101.2 degrees. So the temp, should it be positive or negative, this change in temperature? What do you think? Well, the temp went down, so our derivative, we should get some sort of negative answer for it to be correct, because it seems like it's going down at 4 hours. So I'm getting negative 0.225. It's still decreasing after this. We know 4 hours after taking medicine, it's still in your bloodstream working at least a little bit. This is bringing it down negative 0.225 degrees Fahrenheit per hour. So how we would interpret this on WebAssign, we would say 4 hours after taking the medicine, the patient's temp is what? Is it increasing or decreasing? Negative answer means it is decreasing. It is decreasing at a rate of, and remember we already said decreasing, so we don't want to do decreasing by a negative because that would mean it's really positive. So this I would say decreasing at a rate of, and I'd round to wherever they told me to, but I'm not going to round this one because it's just 3 decimals. So decreasing at a rate of 0.225 degrees per hour. And that's always degrees Fahrenheit for this problem.